Hello and welcome to a new episode of the Path to DevOps series. I'm Shiki and I would like to invite you by the campfire on this pit stop that is today's episode on the Path to DevOps series. Last time we implemented a Helm chart to deploy to Kubernetes and we think that the worst is behind us, right? Well, that's not exactly true, but now that we have the Helm chart, we can rely on it to add new functionality to deploying our application. And today we're going to do exactly that. We're going to add an Ingress object to the chart, mainly to the frontend microservice, and this would give more logic to the application. Now, don't worry if you don't know anything about ingresses. I have a video somewhere here prepared for you, and it will be linked at the end of the video and also in the description down below. With that in mind, let's jump straight into business. But before starting the implementation, as usual, I have to defend the reason why I'm proposing we use an Ingress object. And I have three reasons actually. The first one is, if you look at the web page here, it says not secure. This means we're HTTP, not HTTPS. And this is the first reason. Obviously, we want to transition to HTTPS so that our website is secure and people want to consume our content. Otherwise, they wouldn't have the confidence to click on the link when the link is HTTP. Then the problem is the OSI stack. We're now exposing the front end through a Kubernetes service, which is layer 4, transport layer in the OSI stack. In order to have HTTP functionality, well, HTTP and HTTPS, they sit at layer 7, application layer. So we would need a sort of load balancer which understands application layer, and that is the Ingress controller, which is why I suggest we transition to that. Then the third reason is we are using an IP, not a host name. Now, the Ingress will make it easier for us to use a host name in order to serve our application to the world. And I will show you how to do that in a future video, not in this one. Trust me, there is a lot of content in this video as well. And I'll actually give you a fourth reason, which is not really a reason, but think about the name of the object. It's called an ingress, not a service. Service, what does this do? Well, basically it services requests, but ingress, it's basically the entry point for traffic in the cluster. So technically, if you think about the naming conventions, which are supposed to make sense, Kubernetes developers and architects are trying to tell us that we should use the ingress object to take traffic inside the cluster through it. And that's exactly what we plan to do today. Let's start adding the ingress to the Helm chart. Just a quick reminder that all changes we're going to do in this episode, you will be able to find on the feature/01_adding_ingress branch in my GitHub account. So this will be added after I finish the video. So you can follow along and download the code, play with it and understand it. Now, interlude out. As you guys can see, we are now in the tools repository, which contains the Helm chart we created in the previous episode. And this tools repository is the repository from the Azure DevOps organization that I'm using for this Path to DevOps journey. So what we need to do now is git branch, and as you can see, I'm on the master branch. Now I want to be adding the ingress object. So git checkout -b feature/adding ingress. There we go. So now we should have a new branch called feature adding ingress where we can add our ingress. The first thing we need to do is to actually add the ingress.yaml file. And in here, first things first, not all three of our microservices are going to need an ingress object. So we kind of need to make this conditional. So we can do that by using a simple if clause in the Helm templating language, and it looks sort of like this. Dot values, so we need to say if, and then we need to create a new key in the values.yaml file. In this case, let's call it values.ingress.enabled. If the value of this key equals true, then everything in this template will render successfully. So we need to end this with an end clause. like this. Yeah. And now we need to put Ingress logic inside of it. So how are we going to do that? Well, very simple. We just need to Google it. So Kubernetes Ingress. Yeah, it's all official documentation, and that's what I will always encourage you to do. Just Google it, search online for the solution if you don't know it. So Ingress backed by a single service. This looks kind of like the scenario we're in right now. Yeah. So we have it here. Let's just copy this and add it here. And now we just need to take the app name from here, and the name of the ingress is going to be the same as for the other objects. Yeah, values.appName. The name of the service is also going to be the same. If you look at the service, you see the name is also values.appName, and then the port is going to be values.service.port. Yeah, there we go. This is how it's supposed to look. Now the ingress needs one more object which isn't declared there, but it's basically the ingress class name. So basically what ingress controller will take care of our ingress object. And we also need some annotations here because we want to implement some fancy logic in the future. So we will need annotations. And in order to do that, I will actually want to inject those annotations from the values.yaml file. So what we're going to do is, let's write this logic together. With .values.ingress .annotations, yeah, and then annotations, and then we to YAML. Yeah, this is a function that's already available, and an indent 4 because we want 4 spaces in here. Yeah, and then we also need the end for this with clause. Okay, this is basically how it's supposed to look. So now that we've created our ingress object and we are fond of it, let's actually add the necessary values in the values.yaml file. So the first one is we need to create this key here, values.ingress. So let's put it at the bottom. There we go. And under it, we need enabled. Yeah, so in here, if you see ingress enabled, so this needs to be a Boolean, and it will actually come from a variable because for the front end, we want the ingress object to be available, but for the backends, we don't want to render the ingress template. The only application for which we are rendering the ingress template is the front end. Yeah, so we need a variable here which tells us if the ingress is enabled. So we can call it ingress enabled. Yeah, something like this. Then we need the class name. Yeah, so we can copy this and we can put it here. And the class name is always going to be nginx because we are going to be using the nginx ingress controller. And then we're also going to need annotations. Yeah, in here. And this looks good. Now, in terms of annotations, what I propose we do is we don't leave our application exposed to the internet permanently so that anyone can access it. Instead, what I would propose is so we can look at annotations. And in here, you can see there are some authentication. And if we look here, you can see that it is possible to add authentication by adding additional annotations to the ingress rule. The source of the authentication is a secret that contains usernames and passwords. So basically, whoever wants to access our front end, only the people who know the username and password will be able to basically authenticate into the browser and be able to see the front end. So this sounds like a cool solution. So basically, we need to add these annotations here. So auth type, let's make it basic authentication. Then the name of the secret, the name of the Kubernetes secret, which needs to contain the username and password, and I'll call it like this. Yeah. And the secret type, and the one that I worked with is auth file, and I'll show you how to create it in just a few moments. And also the authentication realm, which in our case can be anything as simple as authentication required. Yeah. So right now, when someone would access the application through our Ingress, they would be prompted for basic authentication, and they would need to input a username and password, which will be stored in Kubernetes in a secret. That's basically how the logic would work. Now, let's add everything. Okay, and let's push. There we go. So now if we go to Azure DevOps and we search for branches, you see that we now have the adding ingress, which was added just now to our tools repository. In order to test the changes we made to the chart, I only want to deploy the front-end application with the changes. So in order to do that in isolation, I created a new branch, also called feature/adding ingress on the front-end. And I modified the deployment chart to use the tools repository from the feature adding ingress branch. Okay, so in this case, the cart API and the product API will be using the master version of the Helm chart, the one which doesn't contain the ingress yet, and that's totally fine. But for the front end, I need to deploy using the ingress, which is why I made this alternative branch to add the reference to the feature adding ingress branch from the tools repository. Okay, that's the only change we need to make in order for this to work. Now there's one more thing that we need to do, which is in the library of the front end, we need to add ingress enabled true. Okay, and in this case, our ingress template will render. Okay, but aside from this, we also need the service type not to be load balancer. We can actually change the front-end service type from load balancer to cluster IP. And right now, we are going to have the cart API, the product API, and the front-end as cluster IP services, so they're not exposed to the internet. However, we have the ingress object that is taking traffic through the ingress controller inside of the cluster. And I'll show you what I mean by that in just a few moments. You can see that right now, everything in the cluster is deployed with the previous version. Yeah, so the backends are cluster IP, or the backends have cluster IP services, while the front end is still a load balancer service and is exposed through that load balancer service over the internet. Now we want to deploy only the front end using the feature that we added in the Helm chart, which is having an ingress created. In order to do that, it's fairly simple. We just need to run the front-end deploy pipeline from the feature adding ingress branch, which references the Helm chart in the feature adding ingress branch that contains the ingress object. Okay, so running this should result in the front end becoming also cluster IP, and then kubectl get ingress would also return an object. Okay, right now we have no ingresses in the cluster and the front end is load balancer. So let's see what happens post deployment. Right now the pipeline is running, it's analyzing. And there we go. Yeah, deployment was successful. So now if we get the services, you will see that all of them are of type cluster IP. So now we are not exposing applications over the internet through services, through Kubernetes services. We're actually going to do it through the Ingress, okay? But as you can see, there's a problem because we have no IP address here. And this reason is very simple. It's because we don't have an Ingress controller installed. Yeah, so we've created an Ingress object, but as I mentioned in the beginning of the video, we need to know more about ingresses. So Ingress objects, you can deploy them in the Kubernetes cluster, but an Ingress controller, which is the entity inside of Kubernetes that controls Ingress objects, does not come by default with Kubernetes. So you need to deploy your own custom Ingress controller. And not to worry, it's not as complicated as it seems. There are a lot of alternatives on the internet. So one of them is Ingress-nginx. Yeah, and if we open the GitHub link, you have here charts, so you can install the Ingress-nginx controller using a Helm chart. And if you go here, you will see that it's fairly simple. You just need to run 3 simple commands. You update it, and then this is how you're basically deploying, okay? I will install my controller. Actually, let's create a namespace for it. Yeah, a specific namespace. So let's do kubectl create namespace networking, let's say. And then when we install the Ingress controller, let's do it in the networking namespace. And it will take a couple of seconds, but after all this, we will have an Ingress controller running in our cluster. A few moments later. All right, there we go. So this was successfully deployed. If we do a helm ls in the networking namespace, you will see that we have the controller deployed successfully here. And if we do kubectl get pods, yeah, we have a pod that's already running. So right now, let's look at the Ingress. And as you can see right now, the Ingress object received an IP address. Yeah, fairly simple. So we take this IP address, we add it to our browser, and it's still not working. Let's see why. And this is an educational series, so we want to understand what's happening. As I've shown you, the Ingress controller is also running in a pod in the networking namespace, so we can actually look at its logs. kubectl logs namespace networking. And you will see here that we're getting 503 from the load balancer agent. This is interesting. And I know where the error is coming from, but I want to show you guys as well. So if we open the Azure portal, one second, I need to authenticate the request. And here we are. Yeah, so this is the subscription that I've deployed everything into. And if we open resources, you'll see here there's a Kubernetes load balancer. And basically the problem we're having is because we added authentication on the Ingress, the load balancer health probes, which are HTTP and HTTPS, don't have authentication on them. So they probably aren't able to get to the cluster. Okay, so let's open Insights. I'm curious. And yeah, exactly right. So if you look at the Insights tab, let me move myself here. You will see that the load balancer isn't actually getting to the backend pool. Yeah, for some reason, this is failing. And a very simple way to fix this is to go to health probes, and actually I'm going to take this health probe right here, copy the port and switch it to a TCP probe. And what this does is right now it will check for the socket to be open instead of making an HTTP request. Yeah, so the load balancer, when it's trying to see if the nodes are up and running, it's no longer going to send an HTTP GET request, It's actually going to see if the socket on that port is open, and that's it. And basically that means the node is running and it's successful. So let's do the same thing for HTTPS. I'll copy the port and switch the probe to TCP. Now, obviously, adding basic authentication here on the Ingress, as we're doing, isn't necessary, and you don't need to do these changes. I just want to do it to show you how powerful the Ingress object can be, and actually having layer 7 objects instead of using a layer 4 service, how many features it can offer you. So now the health probes are updated. Once we've made the load balancer changes, let's follow the logs of the Ingress controller and hit the IP address of the Ingress one more time. And as you can see here, we're getting 503s. Yeah, we're just getting 503s thrown out. And that is very simple. If you remember, in the Ingress configuration, we said that we're going to have authentication, basic authentication, and the username and password for that basic authentication is going to sit in a secret called exactly like this, yeah, Ingress basic auth. And obviously we didn't create this secret yet, so we need to create it right now. And we're going to be using a toolkit called htpasswd, yeah. But I'm not going to install this. I'm just going to use an online tool. Yeah. So as you can see, I've used this before. I wouldn't recommend you do this with production applications. Yeah. Who knows where this gets saved. But anyway, in my case, this is a demo and I will be deleting the infrastructure afterwards. So let's just use Marco and Polo as username and password. And it generates this random string for us, as you can see here. I will copy it, and if we look at the auth example, which we have here, yeah, it tells you that basic authentication. This example shows you how to add authentication in an Ingress rule using a secret that contains a file generated with htpasswd. It's important the file generated is named auth. Okay, so this is very important. You need to create a file. Yeah, I will create it here in the tools repo, but I will not push it. That's very important. Yeah, I will just call it auth. Okay, and I will add this in here, as you can see right now. And then we just need to kubectl create secret. In our case, we need to change the name a bit because it's not called basic auth. It's actually called Ingress basic auth. And also, oh, sorry, there we go. And also we want to deploy it in the namespace shiki-ns. Yeah, so when we do this, kubectl get secret namespace, you will see that we created this basic authentication secret 9 seconds ago. So now when we go to this and we refresh, there you go, sign in, and we are prompted to insert a username and password. In our case, it's going to be Marco and then Polo. And when you hit enter, you are going to have access to your front-end application, which is obviously connected to the backends. And because visuals speak best to anyone, let's see what the differences are now that we added the Ingress and the Ingress controller. So previously we had this setup where the front end had the load balancer type service and cart API had cluster IP and product API had cluster IP type service respectively. When a user wanted to access the application, they would go through a layer 4 load balancer, and the traffic would then be directed through the load balancer service into the front end, and the front end would use the cluster IP type services to communicate with the backends. Now that we inserted the Ingress, basically the changes are that the front end also has a cluster IP type service, so this is no longer exposed to the internet. We now have a layer 7 Ingress controller sitting on top, and we have the Ingress object, which is the template we added in the chart, and this is basically the route which directs traffic into the front-end service. And the traffic flows like this right now, but the front-end is still using the cluster IP type services for cart API and product API to communicate with them. In terms of architecture, there are not huge changes, but as you can see, you can do a lot of cool stuff with Ingress objects, including adding basic authentication to your web page. So right now, when someone wants to access your web page, they need to input the username and password, in our case Marco and Polo, and otherwise they won't be able to access the front page. Yeah, let's just check this out one more time. Let's copy the IP address, let's open an incognito tab, and if I just put this, see, it doesn't let me. Yeah, so I'm not allowed unless I put in Marco and then Polo. And right now I'm able to access the front end. The only thing that's left for us to do is to bring the changes from the tools repo. So basically the changes where we added the Ingress object into master. So as you can see here, you updated this branch, create a pull request. Yeah, sure, I want to do that. So I'm bringing the changes into master and I'm completing this and I'm deleting the branch after merging. And there we go. Now the changes of the Helm chart should be in the master branch. And also you need to make sure on your variable groups for all three of your microservices that you have this ingress enabled, which is true for the front end. But for the two backends, you need to make it false. Yeah, so you don't need ingress objects for the backends. You are not exposing the backends to the public for consumption. Okay, and right now if we redeploy one more time using the latest version of the chart, everything should go out smoothly. Okay guys, this is it for today. I hope you enjoyed this sneak peek into the Ingress object. We are going to be using the Ingress object and improving it in the future videos because, as I said, we want to have an HTTPS connection. So we need to make the website secure, and also we want to have a host name instead of an IP address, something like myfrontend.com or whatever. We'll do that in the future videos, but until now, thank you for your time of the day, and I wish you a great one wherever you are. Cheers, see you next time.